This is the exam review for semester 2 for grade 9, and the subject is chemistry. Ionic bonding. This is the electrostatic force between two opposite ions. Usually occurs between metal and non-metal. The metals are usually found in column 1 and 2, or groups 1 and 2. These tend to lose electrons to form a positive ion, while non-metals are found from column 13 and 8 to 18. These tend to gain electrons to form negative ions. An example of ionic bonding is NaCl. Na is in column 1, so therefore it's a metal, and it loses an electron to become Na+. Cl is in column 17. These tend to gain an electron to become Cl-. So if we were to draw the ionic bond, we've got Na. This has 1 electron, plus Cl. This has 7 electrons. Remember, to show the transfer of electrons, we draw an arrow. This becomes Na+, because it has lost an electron, and Cl-. This is called the Lewis dot symbol. And to do the chemical formula, remember we use the crisscross. Na+, Cl-, becomes NaCl. Then we looked at electrochemistry. The first lesson was about assigning oxidation numbers. We said the oxidation number of any pure element, for example Fe, I2, Cl2, O2, all of these have an oxidation number of 0. The oxidation numbers in column 1 is +1, the oxidation number in column 2 is +2, the oxidation number in Al is +3, the oxidation number in F, so in fluorine, in compound is -1, and any element that's found in column 17 is also -1. The oxidation number of oxygen in compound is -2, and there's an exception on oxygen. If it's in H2O2, it's -1. And hydrogen with non-metals, for example hydrogen fluoride or hydrogen chloride, the hydrogen has a oxidation number of +1. We then looked at the oxidation numbers for ions. There are 2 types of ions, monoatomic ions and polyatomic ions. We're first going to focus on monoatomic ions. So for example, Cl- has a charge of -1. Here's where you see the charge, so the oxidation number is -1. O2-, oxygen has a charge of 2-, so the oxidation number is -2, and so on. For polyatomic ions, it's the sum of the oxidation numbers of all atoms is equal to its charge. For example, you've got NH4+, so it's the oxidation number of nitrogen plus 4 oxidations of hydrogens, because there's 4 hydrogens, and that equals to +1. Therefore, if you want to find out the oxidation number for nitrogen, you know that the oxidation number of hydrogen is 4, and you just do simple substitution. So if there's a change in the oxidation number, we call this a redox reaction. So oxidation and reduction has to happen in the same time. We've got here the oxidation number of carbon is 0. The oxidation number of oxygen by itself, a pure element, is 0. The oxidation number of oxygen, we said in a compound, is always -2, so we need to find out the oxidation number of carbon. So we use this equation: oxidation number of carbon plus 2 oxidation, because we've got 2 here, it's the 2 oxidation number of oxygen, which equals 0. We have to rearrange the equation to make carbon, the subject. We then do substitution. We know that the oxidation number of oxygen is -2. -2 times -2 is +4. So the oxidation number of carbon here is +4. So from 0 to +4, the oxidation number increases. So this is the loss of electrons. So this is oxidation. And here the oxidation number decreases. So here the oxidation number decreases. So it has gained electrons. So reduction has occurred. Because oxidation and reduction is happening at the same time, this is a redox reaction. We then looked at the combination of two half reactions. So for example, if we have this equation here, we first write the oxidation numbers. So these are 0. Oxidation number of the oxygen in a compound is -2. So this must be +2. As it's a neutral compound, you can do it by calculation too. So to write the half equations, Mg, it has lost 2 electrons to become Mg +2. So we write the 2 electrons on the right hand side of the arrow. The oxygen has gained 2 electrons, but we've got 2 oxygen, so we write 2O2 minus, and it's gained 4 electrons. We then have to get rid of the electrons, so we times this by 2. Remember, this is called the oxidation half reaction. Or half equation. This is called the reduction half equation. We times the Mg by 2, so that's 2Mg, 2Mg2 plus 4 electrons. The other one stays the same, the reduction half equation. 4 electrons cancel out to become 2Mg plus O2, which equals 2Mg2 plus 2O2 minus. So remember, we take 2 as the common factor, so we do 2Mg plus O2. Take out 2 as the common factor, which is Mg2 plus O2 minus. We crisscross this, so the 2 numbers will cancel out, and then we have the final equation looking like this. So then we looked at the reaction between copper and zinc sulfate. Remember, we drew it like this. So if we have here kind of a beaker, we put a copper inside here filled with zinc sulfate, which we said is colorless, that's why I'm drawing it in white. So here it's filled with zinc sulfate. So here we've got zinc sulfate, so we've got zinc 2+ ions and SO4 2- ions, and this is copper. And we said here that we don't have a reaction because Cu is less reactive than zinc 2+. We then saw the reaction of copper sulfate with zinc. We drew this like this. So this is reaction 1. So is reaction 2. So if we put a zinc metal in here, and we put here copper sulfate, remember copper Cu2+ is blue, which gives, so therefore the solution is blue. So we have here Cu2+ ions and SO4 2- ions. And we said that the equation for this reaction is Cu2+ plus zinc Zn equals Cu solid plus zinc 2+, and because there's a change in oxidation numbers, see Cu2+ went to Cu0 and zinc went to zinc's oxidation number has 0, and the oxidation number of zinc +2 has an oxidation number of +2, therefore redox has taken place and therefore a chemical reaction is also happening. And the evidence that this reaction took place is that there is a change in colour, so the blue will disappear because the Cu2+ will change into Cu. Red deposits, so here red deposits will be found on the zinc metal, so release of heat because it's a redox reaction, and the zinc strip will become thinner. So this zinc strip located here will become thinner. We will now do the questions in the exam review. The first question states that the constituents of glass vary according to its synthesized types and its usages. Nevertheless, the most commercial type of glass, or ordinary glass, is formed of 3 main constituents: silicon oxide, calcium oxide, and sodium oxide. The first question says, determine, referring to the above section of the periodic table, the atomic number of the oxygen element. So, O is in row 2. It has 2 energy shells. Which are K and L. Column 16. It has 6 electrons in its outer shell. Therefore, the electronic configuration is K2L6. Therefore, the number of electrons is two plus 6. Remember, we use the numbers that are located here, which is 8 in a neutral atom. number of electrons equals number of protons, so that equals 82. So the atomic number, which equals the number of protons, equals 8. The second question says, given the atomic symbol 18 argon, 18 Ar, specify its location, so the row and the group in the periodic table. So first, this is the number of protons. So we have to say we need the number of electrons to write the electronic configuration, so we can know the row and group. So in a neutral atom, number of protons equals number of electrons. So the number of electrons is also equal to 18. We can write the electronic configuration, which is K2L8M8. So 8 plus 2 is 10, plus 8 is 18. It's got 3 energy levels, so it's got 3 energy levels. That means it's in row 3, and since it has 8 electrons in its outer energy level, it means it's in group 8. So it says write the Lewis dot symbol for Na and O. So the Lewis dot symbol is the chemical symbol surrounded by the valence electrons. So Na looks like this because it's in group 1, and O looks like this because it's in group 6. So for this question, it says explain the formation of the bond between Na and O. Here you do not write the Lewis dot symbol, okay? It says here, the second question says Lewis dot symbol, so here you just have to explain the formation. So you write each Na loses 1 electron to become Na plus. O will gain 2 electrons to become O2 minus. There is an electrostatic attraction or force between each of the Na plus ions and O2 minus ion, forming an ionic bond. Now it says write the Lewis dot symbol for the above formation and the formula unit. So we've got 2 NAs. Oxygen looks like this. Remember, transfer electrons, we draw arrows. So this becomes 2 Na plus and O2 minus 2 minus. We then need to write the formula unit as well. So this is where we use the crisscross. Okay, so that will be Na2 O. The synthesis reaction of calcium oxide is represented by the following equation. Justify using the oxidation number that this equation is a redox reaction. So first let us write the equation. So the oxidation number of a pure element is 0. Oxidation number of oxygen is always -2. Therefore calcium is going to be +2, or you can do it by calculation. Now, first, here, the calcium, the oxidation number has increased, therefore it's oxidation. Here, the oxidation number has decreased, therefore it's reduction. So now we just have to write it in word form. Ca, so in calcium, oxidation number has increased from 0 to +2. Therefore oxidation has occurred. Oxidation is the loss of electrons. NO, oxidation number has decreased from 0 to -2. For reduction has occurred. Reduction is the gain of electrons, since oxidation and reduction is happening at the same time. This is a redox reaction. So now we have to write the oxidation half reactions. So calcium went from calcium to calcium 2 plus, so it lost 2 electrons, so we write the 2 electrons here. Oxygen went from O2 to O2 minus, but remember we've got 2 oxygens here, so we write 2. One oxygen has gained 2 electrons, so the 2 oxygens will gain 4 electrons. Okay, so it says oxidation half reactions. We don't have to do more than this. So this is oxidation half equation, and this is the reduction half equation. So indicate the oxidizing agent and the reducing agent in this reaction. It says indicate, so we do not justify. Calcium is the reducing agent. And O2 is the oxidizing agent. So question 2 is about nitrogen dioxide. Nitrogen dioxide, NO2, is an atmospheric pollutant. It contributes to acid formation. In industrialized countries, the level of nitrogen dioxide in air is measured periodically. Nitrogen dioxide can be produced by the following equation. So this is the equation, N2 to O2 equals 2NO2. Indicate the oxidation number of nitrogen atom, and N2, remember, indicates we do not justify, and always the oxidation number of a pure element is equal to 0. Then it says determine the oxidation number of nitrogen atom in NO2. Therefore it says determine, so we have to use calculation. So the oxidation number of nitrogen plus 2, you see, because there's here 2, we have to write 2. It's because there's 2 oxygens, we have to write 2. Oxidation number of oxygen equals 0. Rearrange the equation to make oxidation number of N the subject. Minus 2 minus, so we know the oxidation number for oxygen is minus 2, so therefore minus 2 times minus 2 is plus 4. So the oxidation number of nitrogen is plus 4. Show that N2 is a reducing agent in the above reaction, so we can write since the oxidation number has increased from 0 to plus 4, it means N has gained 4 electrons. Therefore, it is a reducing agent. Question 3 is about dates. It says dates are a traditional and popular food. Eating dates after fasting helps to maintain blood sugar levels and is an excellent source of dietary fiber, potassium, magnesium, and complex sugars. Potassium is an important component of cell and body fluids that help control heart rate and blood pressure. Magnesium is essential for bone growth. They are a moderate source of vitamin A, which is known to have antioxidant properties and essential for vision. First question states, pick up the names of 2 chemical elements mentioned in the passage. So that is potassium and magnesium. Give the atomic number of the element potassium. So it says 19K, and write the electron configuration of the potassium element. So Z equals atomic number. So we've dealt with the first part, which equals 19 in the neutral atom. Number of protons equals number of electrons, which equals also 19. So the number of electrons is 19. So the electronic configuration is K2, L8, M8, N1. Third question says the element potassium combines with the element sulfur to form an ionic bond called potassium sulfide. Describe the bond formation in the potassium sulfide. So it says the bond formation. So we don't draw the Lewis dot symbol or the chemical formula, we just write each K will lose one electron to become K plus. S will gain 2 electrons to become S2 minus. There is an electrostatic attraction between the K plus and S2 minus ion, forming an ionic bond. The element hydrogen combines with the element sulfur to form the molecular compound hydrogen sulfide. Write the Lewis electron dot symbol for hydrogen sulfide molecule and identify the type of bonds between the atoms of this molecule. Now we have to decide if this is going to undergo ionic bonding or covalent bonding. First of all, we know that one hydrogen is a non-metal, so its electron configuration is like this. Now we have to decide if sulfur is a non-metal. So we need to write first its electronic configuration. So it's K2, L8, M6. The fact that it has 6 electrons in its energy shell, in its outer energy shells, it shows us that it's in group 6. Group 6 are non-metals. So this one is a non-metal, and this is also a non-metal. Therefore, it will undergo covalent bonding, not ionic bonding. Okay, so we can write sulfur. It's got 6 electrons in its outer cell, so the Lewis dot symbol is like this. Hydrogen has 1, so they will undergo bonding like this. So the Lewis dot structure will look like this. When you have 2 electrons like this, we can just draw them as a line. Now it says identify the types of bonds between the atoms. Identify with justification. So each H will need 1 electron to satisfy the duet rule. Remember, hydrogen undergoes duet rule. S will need 2 electrons to satisfy the octet rule. So each H will share 1 electron with S. Therefore, H and S will be saturated. forming two single covalent bonds. Two single covalent bonds. By referring to the text, name the element that helps in controlling blood pressure. So if you read the text, you will see it is potassium. Question 4 is about isotopes. It says silicon is a hard and brittle crystalline solid with a blue-grey metallic luster. It is a tetravalent metalloid and a semiconductor. Silicon consists of 3 isotopes. The relative percentage abundance of these isotopes is given below. So it says represent on a circle graph the relative percentage abundance of the 3 kinds of silicon atoms. So it's given to us in percentages, so we have to convert this into degrees. So the 28 silicon, so we do 90, that's 100%. We want 360, so we do cross multiplication, which equals 90 times 360 divided by 100 equals 324 degrees, or we can just times it by 3.6, which I'll do for the rest. So the 29 silicon, we do 6 times 3.6, which equals 21.6. It ends with 0.6, so we can round up to 22 degrees. And 30 silicon is 4 times 3.6, which equals 14.4. Ends with 4, so we round down, so it's 14 degrees. Now, as you can see, this is how the circle graph should look like. It says identify the most abundant isotope. So this one, the one that has the highest relative abundance. So 28 silicon is the most abundant isotope since it has the highest relative abundance, which is 90%. Knowing that silicon has 14 charged particles in its nucleus, copy and complete the following table. Now we know that it's 14 charged particles, so Z equals atomic number, which equals number of protons, so that equals 14. So all of them has 14 in a neutral atom, so 4 electrons in a neutral atom. Number of protons equals number of electrons, so this also equals 14. To find out the number of neutrons, neutrons equals A minus Z. We know that the A is 28. We know here, we got this number from here, this is A, minus Z is 14, so that equals 14. Here it's 29 minus 14, so that equals 15, and here 30 minus 14, which equals here 16. Next question says calculate the nuclear charge and the electron charge of the silicon atom. So the charge is, remember, is represented by Q, the Q nucleus. So the nucleus contains protons and neutrons, so it's the number of protons times charge of one proton plus number of neutrons times charge of one neutron. This is 0. Neutrons don't have charge, so this equals 14 times plus 1, which equals plus 14. Remember, the charge is really important. The charge of the electrons is the number of electrons times charge of one electron that's 14 times by minus 1, which equals minus 14. So the last question says deduce the charge of the atom. So the Q of the atom equals the charge of the nucleus plus the charge of the cloud. Okay, so the charge of the nucleus is the charge of the protons plus charge of the neutrons plus charge of the electrons. We said that the charge of the nucleus is 0. We found out that the charge of the protons is plus 14 and the charge of the electrons is minus 14. So therefore this equals 0, so it's neutral.